Good morning. This is Ms. Billerbeck, and we are going to talk about 12.2 cylinders. So we use cylinders all the time. So we use cylinders for our water bottles. Okay, so our water bottles have an end here and they have an end here. Okay, so we have to make sure we include those ends when we think about cylinders. Okay, so a cylinder has a base here and a base here. So this R right here is called the base radius. And the height of the cylinder is H. Then we have, if we were to cut this can or the cylinder apart and unwind it, it would lay flat like a rectangle with two circles here and here. So that's the base radius right here. Okay, so the volume of the cylinder can be then written. So I have a base here, so a base area here times the height. So as you're filling this up with water, as the height increases, so does the volume. So we can write for the volume of a cylinder, it's pi r squared h, okay, for the base area times the height. Okay, so let's look at the surface area now. So total surface area of a closed cylinder. Now, remember I said you had to have a closed cylinder, so you can't just have, lose a base here. So we had to have a closed cylinder. So we have 2 times the base area to get the surface area, plus the lateral area. So the lateral area is just all around here, okay? So if we look at, well, how do we find the lateral area? So we look at, instead of finding the flat area, we need to find the outside of this circle, or otherwise known as the circumference, which is 2 pi r. So then if we lay out that outer rim here, this length here is 2 pi r, and this length here is the height of the cylinder right here. So the area of this lateral surface would be 2 pi r times h. And that's exactly what the surface area formula is. So we have 2 pi r squared for 2 times the base areas of the cylinder plus the circumference of that cylinder times the height. And that gives us the lateral area, circumference times height. All right, let's look at a few examples now. So a solid cylinder has a base radius of 2 inches and a height of 7 inches. So we draw that quickly. We have 2 inches and a height of 7 inches. Okay, so you can do little hidden lines there. Okay, so find the volume and the surface area. So the volume is pi r squared h. So we have pi and then 2 squared times 7, which gives us, actually, let me include these units. Excuse me. Let me include the units. 2 inches squared times 7 inches. Okay, so then we have volume equals pi times, and that's 4 inches squared times 7 inches. So we end up getting 4 times 7 is 28 pi inches cubed. Okay, so volume, we have 3-dimensional units, okay, as opposed to surface area. So surface area, we have 2 times the base areas, so 2 times pi, and then 4 inches squared, plus the circumference, 2 pi r, times the height, 7 inches. Okay, so 4 squared, 16. 16 times 2 is 32 pi inches squared plus, and 2 times 2 is 4. 4 times 7 is 28 pi inches squared. And then when we add this together, we get the surface area equals, and then 32 plus 28, so that gives me 3060 pi inches squared. Okay, so let's double check everything. So we had 2 pi r squared, which is 2 bases, 2 pi r, which is the circumference, times the height here. So we have 4 times 7 is 28, 2 times 16. Ah, that's the problem. I thought something was a little up. Okay, so 2 times 2 inches squared. So yeah, that's a 2. All right. Sorry, I just knew something was a little amok there. So let's see. Okay, so 2 times 4 is 8 pi. So 8 plus 28 is 36 pi. Now it's good. Okay. So make sure to check your work on this because there's lots of ways to make errors. So I think I just got that 4 right from there. Okay, so there we have it. My mind works in various ways, so that's why we always have to check our work, okay? So the volume of a cylinder disc is 150 centimeters cubed. Okay, so we have a disc. So we can make something that looks like a kind of a hockey puck. Okay, so we have a disc. And we see the thickness of the disc is 2 centimeters. So that's the height. The thickness of a disc is the height. All right, so we have a volume is 150 centimeters cubed, and our height then is 2 centimeters. So it says find the base radius of the disc to 3 significant figures. So we have volume equals 150 centimeters cubed equals pi, and we don't know what r squared is, r squared times 2 centimeters. So let's divide by 2 pi centimeters on both sides. Okay, we'll take the 2 out of here and make that 75. And 1 of these centimeters and make that centimeters squared. And this all cancels out. So we have r squared left over here. Okay, so if I want to find r equals the square root of r squared. So I am going to put the square root of what's left here. So that's 75 centimeters squared divided by pi. Okay, so my math is good, but when we get to stuff like this, this is a better thing for a calculator to do. Okay, so I'm going to take the square root and take 75 divided by pi and find out what that is. So that's 4.886, and it said 3 significant figures. So 1, 2, 3. So that means I'm going to have to round this to 4.89 centimeters because the square root of centimeter squared is centimeters. So that is the radius. Now I can quickly check that and take this here And I'm going to square it. And then I am going to multiply by the height of 2 and multiply by pi. And there I have it. See, there you have it. It comes out super close to 150. All right, so let's look at the next example. Okay, we have a cylindrical metal bar, length of 18 centimeters. Okay, so we have this bar here that's very long and very narrow. Okay. That one doesn't show so much. Okay, and then this is getting melted down into, and it's recast as a cylinder. Okay, so that's where you get bar stock, because you melt it down into other shapes and make castings that way. Okay, so we have 18 centimeters here. So this one's 18 centimeters. And this has a radius of 2 centimeters. Okay, and then we see that this one has a base radius here of 3 centimeters. So that just helps to draw things out so we know what we're talking about. So this radius is 3 centimeters. Okay, so it says find the height of the new cylinder. So first we find the volume of the first cylinder, the bar. So we have pi r squared, which is 2 centimeters squared, times 18 centimeters. So that gives us pi, and then 4 times 18. So yeah, 18 times 4. So that's 32 and 72. Okay, so we have 72 pi. You should write the number before the pi, 72 pi centimeters cubed. Okay. So now what we're going to do is find, well, what is this new height? So the volume of the cylinder is equal to the volume of the bar. Okay, so we have 72 pi centimeters cubed equals, and then we have pi, and the r is 3 centimeters squared times the height. So if we divide by 9, there we go. The square is in the right spot now. So 3 squared is 9 and pi. So I'm going to divide by 9 pi here and here. Okay. So my height then becomes, the pi's cancel, and there are 8 72s, 8 9s and 72. So 8 centimeters. So the new height is now 8 centimeters. Okay. I cancel that, make that a 1, that's an 8. So that's how we do it. Okay, so that cancels, 3 squared is the same thing as 9, so that cancels, and then we have h. Okay. So the next question is find the total surface area ratio of the bar to the new cylinder. You may ask, why? That seems like a lot of work. Well, you know, if you're plating one versus the other, you might want to know how much plating you need, because plating goes on the outside and sometimes the inside of your cylinders. Okay, so if we find the total surface area ratio, okay, so let's do the surface area of the bar equals, and then we have twice the base area, so pi, and the radius was 2 centimeters squared, plus the circumference, 2 pi R, which is 2 centimeters, times the height, 18 centimeters. Okay, so let's pull the 2 pi out. So we have 2 pi in both of them, so we're pulling it out, and then 2 squared is 4 centimeters squared plus, and 2 times 18 is 36 centimeters squared. Okay, so that gives us in here 40, and then 40 times 2 is 80 pi centimeters squared is the surface area of the bar. So now let's find the surface area of the cylinder. So we have 2 pi, and let's just arrange it like that, 2 pi here, and then we see this, we're doing 2 pi radius squared plus radius times height. Okay, so we're simplifying the formula. So we look at the radius is 3 squared plus 3 times the height, which we don't know. Okay, oh, we do know the height. We found it. Right here, that's the height, 8. Okay, so we have 2 pi, and then we have 9 plus 24. 3 times 8 is 24. So in here, we have 33 times 2, which is 66 pi centimeters squared. Okay, so that's not too bad. And it says find the total surface area ratio of the bar to the new cylinder. Okay, so the bar was 80 pi centimeters to 66. Okay, so we're getting there. So one thing with a ratio, we can't have, we want to reduce it. So these are both reducible by 2 pi. So let's divide this by 2 pi and 2 pi and see what we get. So when we do that, we get 42, and this becomes 33. Okay, so we have a ratio of 40 to 33. So that would make a little more sense that this would be the ratio. We can't really reduce it too much more because we would get a decimal. Okay, so this bar here has a lot more surface area than this cylinder right here. And that would make a lot more sense. This would require a lot more plating than this because this has a lot of internal volume that is not exposed to the outside, as opposed to this has a lot of exposure on the outside. So it would have a lot more surface area, which is a good thing when you're trying to get rid of heat. It's a bad thing when you're trying to keep the heat in. All right, let's look at the last example, which is quite something. Okay. All right, so the external and internal diameters, and let's note this is diameters, very important, of a cylindrical water pipe are 4 centimeters and 3.2 centimeters respectively, and the length of the pipe is 0.5 meters. Okay, so if we look at this and we look at this and we see, oh, centimeters, meters, ooh, that's a problem, isn't it? We have to make sure we don't mix units. Okay, so let's first draw a picture of what we have here. Okay, so we have a pipe. So the pipe has an opening and it has an outside, and it's a very long pipe. So what we're going to do is break it like that in our drawings. So this is how engineers fit things onto drawings that are very long, and they only list critical dimensions. Okay, so then if we want the diameter of the outside, we look, that was 4 centimeters. Let's do 4 centimeters like that. Okay, and the diameter of this inside one, okay, that one, let's make, that was 3.2. Okay, so all of our formulas are using radius. So what we want to do before we start committing ourselves to lots of math is we want to find that radius. So the diameters of 4 would mean the radius of 2 centimeters. So diameter outer would be that. The diameter inner is 3.2, which means the radius inner ends up 1.6 centimeters. Okay, so I just divided 3.2 by 2 really quickly in my head, but let me do it properly like this. So we subtract and we drop the 12 down and we get 1.6. So that's how I got 1.6. Okay, I just divide that by 2. All right, so now we won't make any horrendous errors by using a diameter in an area formula. Okay, not that I didn't do that before, but let's be careful. Okay, so find the volume of the material used in making of the pipe. So volume total is going to be volume outer minus volume inner. Okay. So we have, okay, so let's do volume outer. Then it's going to be pi times r outer, which is 2 centimeters squared, times the height. And the height was 0.5 meters, but we have 100 centimeters equals 1 meter. Okay. So we are going to use a conversion here. So we have 100 centimeters over 1 meter. Okay, so we have 4 here, so 4 pi times, and then when we multiply this out, half of 100 is 50. So we end up with 200 pi centimeters cubed for the outer. And now let's do volume inner. So that's pi times the radius, 1.6 squared, times 0.5 meters, and then we use the conversion again. Okay, so 1.6 squared, let's do that fast. So 36, and then 9, and then 6, 1. So we have 6, 5, 256. Move the decimal 2 spots, so 2.56. So we have 2.56 pi times 50. Okay, so let me reset. All right, so 2.56 times 50. So we have 0, 30, then 25 plus 3 is 28, and then 12, and we move the decimal 2 spots. So this particular one is 128 pi. So let me write that nicely. 128 pi. So now let's subtract the 2. And we are going to take 1 from here, 9. Okay, so we have 2 and 7, so 72 pi. So this ends up 72 pi centimeters cubed. So that's the volume of material used for the pipe. Okay, there we have it. Okay, so the next one's find the total surface area of the pipe. Wow, that's asking a lot, isn't it? Okay, so I'll put a little thing like that. All right, so what we are trying to find then is we have this little annulus portion right here that we had to find that surface area and this little surface area here. So we have 2 annuli to find. Okay, then we have to find this outer surface that goes across like that. Okay. After we find that, then we have to find the inside. Okay. So let's look at how we might do that. So we're going to take, we have to have a strategy. So total surface area is going to be twice 2 pi radius outer squared. Oops, sorry, that we want the, not 2 pi. Silly me. The area of the outer, pi radius outer squared, minus the area of the inner, so pi radius inner squared. Okay, so twice this because I have 1 here and I have 1 here. So I have 2 annuli. So that's going to get me my annulus. Okay, now I have to do the outside. So that's 2 pi radius outer times the height of the pipe plus the inner lateral surface. So pi radius inner times height. Okay, so that's my strategy, and that's what I'm going to try to do. Okay, so let's look at how we might do that. So surface area then is going to be twice, and let's take that pi out since they both have a pi. Twice pi radius outer. So our outer radius was 2. So we have 2 squared minus 1.6 squared plus 2 pi. We're going to take the 2 pi out there and do 2 pi h because it's the same. So what was the h? The h was 0.5 meters times 100 centimeters. Oh, we came up with that's going to be just 50 centimeters. Okay. 50 centimeters is the length, the height. And now we're just going to do 2 minus 1.6 for these 2 radii. Okay, so what I did is I took the 2 pi's out and took them out here. And the h was 50 centimeters because when we were doing this, remember that kept being 50 for the h when we converted it to centimeters. Okay. So we've got that. Now they both have a 2 pi. So let's pull the 2 pi way over here. So 2 pi, and that's 4. And then we had 1.6 squared was 2.56. So we have 4 minus 2.56 plus, well, I guess I'll just keep the 2 pi here. And then this is 2 minus that is 0.4. So let's see what 0.4 times 50 is going to be. So that's 0, 20, boom. So 0.4 of 50 is just 20. So 4, 20, and you move the decimal one spot. So that is what that becomes. So times 20 centimeters squared. Okay. And we have, whoops. Okay. So then we have 4 minus 2.56. So we carry 1 from here. We have 4, 4.1. Oh, okay. So our surface area then is 2 pi. And we have, let's pull the 2 pi out right now. And we have 1.44 plus the 20, because they both had a 2 pi. So I pulled that out. This is equal to 1.44. This is 20. Okay. So now I have the surface area equals 2 times pi times 21.44, which equals, and if I double that, that's 42.88 pi centimeters squared. Make that nice. Okay, so 42.88 centimeters squared. So that's our total surface area of that pipe. Now, the last question. Okay, this is kind of like one of my engineering questions in college. If water flows through the pipe at 10 centimeters a second, find the volume of water delivered in 30 seconds. Okay, so water is flowing through the pipe at 10 centimeters per second. Okay, so that's our rate. 10 centimeters per second. Okay, and we have an opening at that pipe. The opening, so it's flowing 10 centimeters per second, and we want to know how much water is delivered in 30 seconds. So find the volume of water delivered in 30 seconds. Flowing through the pipe at 10 centimeters. I think I'm missing something on that. I think that's 10 centimeters cubed per second, because that would be a volume flow. So if we have 10 centimeters cubed per second and we multiply by 30 seconds, the seconds cancel and we end up with a volume unit. So then we have 10 centimeters times 30 is 300 centimeters cubed. So that was kind of an easy question once we had the units right. So 10 centimeters cubed per second would be a flow rate. And then if you multiply that by 30 seconds, you get 300 centimeters per cubic centimeters. And that's it for cylinders. Aren't you happy? That was a lot of work. All right. Have a wonderful day. Bye-bye.